All right, so most functions we've used so far can be expressed in explicit form. So for example, y equals 3x squared minus 5, the variable y is explicitly written as a function of x. Okay, we've seen lots of them like that throughout the class so far. Now some functions are only defined implicitly. So in this case, y equals 1 over x is defined implicitly by the equation xy equals 1. Now how do we find dy dx for this equation? So we got x and y on the same side. We used to have y by itself, right? Or having f of x or something like that. So all of a sudden now we have x and y together. How do we find that if we essentially have two variables to apply it to? What we have to do, we have to rewrite the equation with y explicitly as a function of x and then differentiate it. So this would be our implicit form, okay? xy equals 1. Our explicit form would be here. This looks more traditional for us. All I did was just solve for y, divided both sides by x. Okay? This we can differentiate. We know how to differentiate 1 over x with respect to x. We don't know how to do this one. Okay, so all I did here, I solved for y, and then I can differentiate that. So that works on really simple equations. All right, what if they get a little bit tougher? Okay, so if it's difficult to solve for y, then we must do it implicitly. All right, we're going to use something called implicit differentiation. So the first thing we got to do, we got to realize what it means to differentiate with respect to x. Up to this point, everything we've done has only had an x in it, really, right? We differentiate one side of the equation. All it has is an x. All our rules apply to differentiating with respect to x. All right, so if you differentiate terms with an x, then you differentiate as normal. So if you just have a 2x, if you have a 3x squared, nothing changes there. Okay, those rules still hold. Now, if we differentiate any term that involves a y, then we have to use a chain rule. Okay, in that case, you're assuming that y is defined implicitly as a differentiable function of x. So let's look at this to see what it's going to look like. All right, so I have a couple examples here, and we're just going to differentiate each one of these with respect to x, just so you can see the difference. The first one here, we have derivative with respect to x, right, dx of x to the third, then we're going to do it with y to the third as well, just to see what it looks like. So first off, we're differentiating with respect to x here. What's the only variable we have? X. So it's easy for us, right? This is just our power rule. What's the derivative of x to the third? 3x squared. Okay, that's simple. Now, in the second one, we have an issue here. We want to differentiate this with respect to x, but all we have is a y, right? All right, so this is where we're going to have to pull in our chain rule for this. So I'm just going to write over here to the side, okay? Just like we did before, we're just going to write it off to the side, and we'll plug our u in here. So I'm going to treat this guy, my y, as, so before when we had x squared plus 3 or something like that in parentheses, we replaced the u for the parentheses and rewrote it. We're going to do the same thing here with the y, because we can't really differentiate it the same way as we do an x. So I'm going to plug this in, okay, and I'm going to make this my y. All right, now I apply the power rule, still 3u squared, correct? Now over here, when I differentiate my y, it's just a variable, right? It's just a variable. Anytime we were differentiating x, you got 1, right? You got the constant, whatever was in front of it. We still basically apply that. This is still going to be 1. The problem is we have to bring a dy dx in there because we just differentiated that with respect to y. All right. So then now when I bring it back together, so we still have our du over here we multiplied by, now I have 3y squared, so I had to plug my y back in, times dy dx. And that's what the derivative of y to the third would be, 3y squared dy dx. Okay? So you still are trying to apply the same rules, the same power rules, but we just have to tack on that dy dx at the end of the day, because it's a variable other than what we are looking for. All right, let's look at the next one. So I want to find the derivative with respect to x for x plus 3y. Now, back to our derivative rules. Anytime we have stuff that's just plus or minus throughout, you just differentiate each individual term, right? What's the derivative of x? 1. Okay, that one's easy. 1. Now we have 3y. Okay, that's not as easy when it's not an x, correct? We just learned that above. So we have to come off to the side. I'm doing these ones here kind of a long way, and as we go through, you'll see kind of the pattern that goes with them. So by the third or fourth problem here, I'm pretty sure you'll be able to kind of trim it a little bit. All right. So I'm bringing 3y down here. So this is actually just going to be 3u. Okay, u is my y term. What's the derivative of y? We just found that in the last one. It's just going to be what? What is it? dy dx, right? Yeah, it's just going to be dy dx. And then I just multiply that back through, so I end up with 3 after I apply the rule here, the constants rule. The u is gone, so I have 3 dy dx. All right, so then back up to the original problem. Differentiated the x, that's 1 plus 3 dy dx. Eventually here, these are just a couple to get the idea of what it's like to differentiate that y term. When we get to the next ones, we're going to get rid of that dy dx and clean this up a little bit. All right, last one, xy squared. So this guy's a power rule, right? So we have x times y squared. Power rule, or not power rule, sorry, product rule. Product rule, we have to use our product rules here, 1d2 plus 2d1. Okay, what's my first term here? X. That one's simple. Now I have to do derivative of y squared. Now, peek up here to this previous one. This was y cubed. We had 3y squared. So we basically applied the power rule and then tacked on a dy dx, right? So what do you think this guy's going to be? 2y dy dx. Okay. Plus 2, which is our y squared, d1. What's the derivative of x? 1. Okay. Now just simplify a little bit. I'm looking at 2xy dy dx plus y squared. Questions on those first 4? All right with that? All right, so now we're going to step it up a little bit. Rafe Snyder, I can see you're ready for it over there. I know you are. All right, so here's our guidelines for implicit differentiation for a longer equation. Those were just a couple individual terms along the way. Now we're going to step it up and go with the full equation. So what you want to do to use implicit differentiation, we want to differentiate both sides of the equation with respect to x. Then we want to collect all the terms involving dy dx on the left side of the equation and move all other terms to the right side of the equation. Then we're going to factor dy dx out of the left side of the equation and solve for dy dx. So this first one, I'm going to put in like each individual step. We're going to go step by step throughout this thing. Okay? It might look like we're writing too much, but this first one I want to break it down as far as possible. All right? So here we go. We're going to take this equation and we want to find d dx for both sides here. We're going to find the derivative with respect to x. So d dx of the whole left side, y cubed plus y squared minus 5y minus x squared equals dx of negative 4. Okay? I'm going to find the derivative of both sides with respect to x. Now, on this left side, if you look at this left side, this is all just separated by pluses and minuses, right? So our rule for that says if you have pluses and minuses separating the different terms, you just differentiate each individual term, right? That was the first rule we learned. Second rule. All right, so we break this down. So I'm going to have d dx of y cubed plus d dx of y squared minus d dx of 5y minus d dx of x squared equals d dx of negative 4. Again, I'm breaking this down farther than we need to right now, but you'll see why. All right, so now we can go through, and we just made a whole bunch of smaller problems within the bigger problem here. Okay, the easy ones are going to be the ones that just have x's in them, right? So the ones like the x squared or the negative 4, we've done hundreds of those. So let's knock those guys out real quick. What's the derivative of x squared? 2x. So we have a minus 2x for this guy. Over on that right side, what's the derivative of negative 4? Derivative of any whole number is 0. There we go. All right, now we have to worry about the y's. Okay, these are the ones we just talked about before. So you essentially apply the same rules that we've been doing, and then kind of tackling that dy dx via the chain rule, right? So the first one, I have y to the third power. What's that going to be? 3y squared and dy dx. Good. Okay. Plus the next one, y squared, is going to be 2y dy dx. Minus 5y. What's that going to be now? 5 dy dx. Okay. So now we have each of the individual terms differentiated now. Okay, so that gets us through to number 2. Collect all the terms with dy dx on the left side of the equation and move all other terms to the right side of the equation. So I have 3 that I'm going to keep on one side, and I'm going to take the 2x over to the right. Okay, so move the 2x over. What do I have to do? Add it. Just add it. So I'm going to have 2x on the right. Okay, now on the left side, every single term has dy dx, correct? All right, so let's factor it out. Dy dx. That's going to leave me then with 3y squared plus 2y minus 5, and that's equal to 2x. Now we're solving for dy dx, right? That's what we wanted to find. What do I have to do? What's my last step? Solve for dy dx. Divide by everything that's in the parentheses, right? Okay. Divide both sides by 3y squared plus 2y minus 5. Do it to the left, you do it to the right. 3y squared plus 2y minus 5. Gone, gone. So then dy dx is equal to this guy right there. All right. How'd that feel? Pretty good. All right. So I got another one right underneath this. I'm going to get you started on this next one. Okay, I'm going to get you started. Then I'm going to give you a couple minutes to try this next one. So first thing we have to do is differentiate both sides, correct? So we're going to go dx of both sides. X to the third minus xy plus xy squared equals dx of 7. So within this one, be careful, we have a product rule and a product rule. All right? Pause this for a second. I'm going to give you a couple minutes to try this. So on this guy, we want to go through, differentiate each term on both sides, correct? What the heck was that? My entire computer shut off, projector shut off, earphone shut off. My projector's just a black screen, it's computer showing. Oh, okay, maybe. All right, that was our glitch for the day. If we're still recording. Hey, we're still recording. That's a good thing. That was weird. All right, so differentiate each individual term. So first one, x to the third power. That guy is going to be what? 3x squared. Good. All right, now the next two terms we have there, we have the negative xy plus xy squared, right? Those are both going to be product rules. So I'm going to come over here to the side. I'm going to bring that xy over here. Okay, I'm just going to leave that negative there for now. Kind of personal preference. So I'm going to pull that xy over there. So xy 1d2 plus 2d1. 1 d2, what's the derivative of y going to be? 1, but I have to include dy dx, correct? All right, plus 2 d1, what's the derivative of x? 1. All right, so this is going to be x dy dx plus y. Okay, so I'm going to bring that back in here to where I just set aside from x dy dx plus y. Now the second one I have xy squared. I'm going to bring it over here just so I have some extra room. Same thing, product rule again. 1, which is x, d2. What's the derivative of y squared going to be? 2y dy dx, correct? So I just differentiate that with respect to y. All right, plus 2, which is y squared, d1. Derivative of x is 1. Okay, bring that back over here to my main equation and simplify just a little bit. So that gives me 2xy dy dx plus y squared equals, what's the derivative of 7? 0. All right, so I'm going to go ahead and just distribute that negative sign in that middle term. You guys all right with that? Okay, so I'm going to distribute this, so that'd be negative x dy dx minus y. All right. My handwriting is really bad today. All right, so let's get everything with dy dx on the left, everything else on the right. So we got to subtract over this term. So I have a negative 3x squared on the right. We have to subtract over this term, or add it over, so I have plus y. And then we have this term, right? So that would be minus y squared. Good with that? That leaves me then with just my two dy dx terms. So I'm going to go ahead and factor out the dy dx. What's left from this term? Negative x. What's left from this term? Plus 2xy. Last step, divide it. Negative x plus 2xy. Negative x plus 2xy. That's gone. So dy dx is equal to that. There's really no more simplification we can do there. Things you would want to look for, maybe if you have, so on the bottom, like I see x terms, like I could factor that out. On the top, I don't have x terms I can cancel though. So we can leave it like that. Questions? All right. We've got time to look at one or two more. So let's look at this guy. Find the slope of a graph implicitly. So we've done this quite a few times. We found the derivative of something, and then we just applied it to a certain point. That gave us the slope of the line at that point, right? All right, so we want to determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point root 2, negative 1, root 2. All right. So we find the derivative the first way, just like, or on the first step, find the derivative just like we did with the implicit differentiation on the last two, and then just plug the points in. Okay, it hasn't changed from the process that we learned back at the beginning. All right, so let's go ahead and differentiate this guy. So we're going to find ddx of both sides. We're going to go ddx of x squared plus 4y squared equals ddx of 4. All right, these ones are individual terms, so this one shouldn't be too bad. What's the derivative of x squared? 2x. What's the derivative of 4y squared? Perfect. 8y dy dx. What's derivative of 4? 0. Okay, we only have one term we have to move to the right side now. Is that 2x, right? 8y dy dx equals negative 2x. Divide both sides by what? 8y. So I have dy dx is equal to, simplify a little bit, 2/8 simplifies to 1/4, or just negative x over 4y. And then from there, let's plug it in, because there's nothing else to do there. There's our derivative. We found dy dx for this equation. Now let's take that, plug it in. So we're looking at the point root 2, negative 1 over root 2. So I have that dy dx is equal to, well, on top is my x term. X term is going to be root 2. On the bottom, I have 4 times y. My y is negative 1 over root 2. Okay, start simplifying a little bit. I end up with negative root 2 over negative 4 over root 2. All right, so we got a fraction and a fraction. So let's reciprocate that up. I'll put that top over 1, flip this guy up. So then I'm going to have root 2 over 4. Okay, root 2 times root 2 is going to be root 4. I had two negative terms I multiplied together. So the negatives are going to go away. So I have root 4 over 4. What's square root of 4? 2. So I have 2 over 4, which is 1/2. The slope of the tangent line through that point would be 1/2. Questions? All right, so we got about 5 minutes left. This last one's a little rough. Let's try it. If we don't finish it, we'll finish tomorrow. First off, any questions with this guy? All right with that? All right. All right, here we go. Determine the slope of the graph of 3 x squared plus y squared quantity squared equals 100 xy at the point 3, 1. All right, so already, if you look at that, you see a chain rule on the left side, don't you? Okay, because we have something in parentheses to a power. And then on the right side, we're looking at product rule, right? All right, here we go. So let's differentiate both sides. We have d dx of 3x squared plus y squared squared equals dx of 100 xy. All right, so first one, this is definitely going to be a chain rule function here, right? So let's bring it off to the side, and I'm going to make this 3u squared. All right, and then the inside, my u is going to be x squared plus y squared. All right, differentiate the u term. So this is going to be 6u du. My u prime is then going to be 2x plus 2y dy dx. All right, bring it back together and plug back in. So we have 6x squared plus y squared times derivative, which is 2x plus 2y dy dx. All right, so that's what my left side of my equation is. 6x squared plus y squared, and then 2x plus 2y dy dx. Now the right side. I'm looking at this as a product rule. Okay, we'll treat this as 100x and then y. We'll split it right there. Yeah. Here? This is the derivative of that, so that can go away. So I just found what d dx was. Got me? Okay. All right. So then the right side, we're looking at the 100xy. So we're looking at 1, which is 100x, d2. The derivative of y is going to be 1 dy dx. Okay. Plus 2, which is y, d1, which is going to be what? 100. All right, now both of them have 100, so let's go ahead and just factor this 100 out. 100 x dy dx plus y. So that's what I'm going to have here. 100 x dy dx plus y. Okay, now I have to be able to get my dy dx's on a side by themselves. I get a little problem here though. They're both contained in parentheses, right? Here's one, here's the second one. So what I'm going to do, I probably shouldn't have factored that. Should have just left it out. We'll distribute this guy through. This one here, to get rid of this parentheses, I'm going to go ahead and distribute this 6 through. Okay? We'll do that to start with. So, on the left side, I'm going to have 12x and I want to do this all in one step. I'm going to do this all in one step. I think we can handle it. So I can distribute this guy through here, but then I'm still going to have a set of parentheses, right? I have to multiply each one of these terms. I'm going to get a 12x here, but I still have to multiply 12x by this, right? I take 6 times this, I get 12y dy dx. I still have to multiply it by this as well, right? So I'm going to rewrite this parentheses twice then. So we have 2x, and then x squared, 10, x squared plus y squared, plus 12y, x squared plus y squared, y dx equals 100 x dy dx plus 100 y. All right, get that copy down. Pause right there because we're not going to finish this in the next minute or two. We'll pick this up exactly at this point tomorrow. All right, I won't post any homework tonight because the homework will be, I'll post it Friday after we finish the lesson. Does that make sense? All right, have a good day, guys.